Welcome back everyone. In the previous video, we learned about the electronic components and their symbols. I hope you have clear understanding about individual electronic components. In this video, we'll learn about circuits and how these individual components can be connected together to form a circuit. We see electronic circuit everywhere. Any electronic component you see will be a part of a circuit. It takes sound mind and knowledge to develop a new circuit combining different components, and it can be achieved if you have a strong knowledge about basic circuits. Let's first understand the meaning of a circuit. A circuit is defined as a roughly circular path or a route that starts and finishes at the same time. Now let's see how many types of circuits are there. There are basically two types of circuit. The first one is open and closed circuits. The second one is series and parallel circuits. Let's first discuss open and closed circuits. An open circuit is one where the continuity has been broken by an interruption in the path for current to flow. A closed circuit is one that is complete with good continuity throughout. We discussed about how the current flows in our last video. Let's look at the quick difference between open and closed circuit. In open circuit, it is not a closed and a continuous path. If we talk about closed circuit, it is a closed and a continuous path. In open circuit, electric current doesn't flow in an open circuit. In closed circuit, electric current flows in a closed circuit. The key in an open circuit is shown as two small brackets. The key in a closed circuit is shown as a two small bracket with a dot in the center. Before we start making circuit, let's understand voltage, current, and resistance, and also the relationship between all the three. Let's talk about voltage. Voltage is the potential energy of an electrical supply stored in the form of an electric charges. Voltage can be thought of as a force that pushes electron through the conductor, and the greater the voltage is, the greater is the ability to push the electron through a given circuit. The potential difference between 2 points is measured in volts. The greater the voltage, the greater is the pressure or pushing force, and the greater is the capacity to do work. A constant voltage source is called as a DC voltage, and the unit is volts. Batteries are mostly used to produce a steady DC, that is direct current, such as 5 volt, 12 volt, 24 volt, etc. While AC, that is alternating current, are available for domestic house and industrial power and lighting as well. Let's understand electric current. Electric current is the movement of flow of electric charges and is measured in ampere. It is a continuous and uniform flow called as drift of electron around the circuit that are being pushed by the voltage source. In reality, electrons flow from negative terminal to the positive terminal of battery. And for ease of circuit understanding, conventional current flows assume that current flows from positive to negative terminal. Arrow in the circuit usually indicates the direction of conventional current flow, not necessarily the direction of the actual flow. The flow of electron around the circuit is opposite to the direction of conventional current, from being negative to positive. Let's understand resistance. Resistance is the capacity of a material to resist or prevent the flow of current, or more specifically, the flow of electric charges within the circuit. The circuit element which does this perfectly is called the resistor. Resistance is the circuit element measured in ohms, and the Greek symbol is omega. If you see this water tank, the pressure of the water is the voltage which pushes the water to flow through the tap, where the pipe connected to the tap acts as a conductor for the current of water to flow, and the tap acts as a variable resistance for the water to resist the flow or to stop it. There is a relationship between voltage, current, and resistance as well, which is known as Ohm's law. Let's understand. It is the most fundamental law in electricity, that is Ohm's law, or we can call it V equals to IR. V is the voltage, which means the potential difference between two charges. I is the charges flowing through the conductor per unit time, and R is the resistance resisting the flow of charges. Let's look at the simulation to understand the relationship. If you look at the simulation, V equals to IR, that is Ohm's law, where V is directly proportional to I and the resistance. Let's increase the voltage and see the changes. I am increasing the voltage from 1 volt to 1.5 volt. You'll see the value of the current is much higher as the voltage is directly proportional to the current. Let's increase the resistance. The moment I'm increasing the resistance, the current is getting lower and lower. The current is decreasing. It means that the resistance is trying to resist the flow of the current. This is how we can understand V equals to I relationship. By knowing any two values of the voltage, current or resistance quantities, we can use Ohm's law to find the third missing value. Ohm's law is used extensively in electronic formulas and calculations, so it is very important to understand and accurately remember these formulas. Transposing the standard Ohm's law equation above will give you the following combinations of same equation, which is called as Ohm's law triangle. Then, by using Ohm's law, we can see that a voltage of 1 volt applied to a resistor of 1 ohm will cause a current of 1 ampere to flow, and the greater the resistance value, the less current that will flow for a given applied voltage. Let's make open and closed circuit of our own. Before we start making open and closed circuit, let's look at this component in our lab. This is called breadboard. So we have two kinds of breadboard in our lab. This is a 800 pin breadboard and this is a 400 pin breadboard. So I'm going to use a 400 pin breadboard in this project. If you look closely to this breadboard, you'll be able to see there are two different lines. The first one which is connected horizontally and the second one which is connected vertically. So in horizontal connection, if you power up one pin here, the connections throughout the horizontal pin will be able to get the same voltage or the potential. Similarly, as these are connected vertically, if you power up any single hole here, any single pin here, you'll be able to get the same potential or the signal throughout the pin. So the topmost one, you can see the blue color and the red color, these are connected horizontally, and the number that is from 1 to 30, these are connected vertically. So let's make our first circuit. To understand open and closed circuit, let's take one LED, one compatible resistor. Here I'm using 1 kilo ohm resistor. To power up this device, we need one battery clip and of course one 9-volt battery. Let's connect our 9-volt battery with a battery clip so that we can easily interface our breadboard with the battery supply. So I'm connecting positive to positive, that is red, and negative to negative. As we have discussed, I have given positive supply here, so the line which is in horizontal connection will all get positive voltage. Similarly, the negative will get negative. So as we know, the current flows from positive to negative. I will start connecting from positive. To make it an open circuit, I'll first try to connect one resistor from the positive supply. I have connected somewhere here at the center. Now the current flowing from the battery moves to the resistor and then one LED which is having two terminals, positive and negative. I'll connect the positive side to positive side. Now if you see the circuit, this circuit is called open circuit. Why it is open circuit? Because the connection is not closed yet. We have started from positive, we have not ended to the negative. So it is not making a loop. So it is an open connection. To make it as a closed loop, we have to use one jumper cable. This is a male to male jumper cable. You can easily find it in your lab. I will jump the cable from the negative terminal of the LED to the negative terminal of the battery to make the circuit close. The moment I make the circuit close, you'll be able to see the LED glowing. The LED will glow the moment the circuit gets closed. So this is closed circuit. Closed circuit means a continuous path. The current is flowing through the resistor and then the LED and ending up to the negative terminal. So this is called closed circuit. I hope you get it. Now let's understand series and parallel circuits. As we all know now that the current can only flow in closed circuits, as there will be a defined path of flow of electrons from negative terminals of a battery to positive terminal of a battery. First, let's discuss about series circuit. A series circuit is a circuit in which resistors or load are arranged in a chain so that the current has only one path to take. The current is same throughout the resistor. We can also check with the help of multimeter, which we will see in later part of the video. A parallel circuit is a circuit in which resistor or load are connected in parallel to each other, so that the current flow has multiple paths. but the voltage across each resistor or load is same, which again can be checked with the help of a multimeter. Both series and parallel circuits have their advantages and disadvantages, and hence we may also use a combination of the both. Let's understand the advantages and disadvantages of series circuit first. If we talk about advantages, we know that the series circuit do not get heated easily. Therefore, any dry or flammable object placed near the series circuit will not catch fire in case of overheating of the circuit. Talking about disadvantages, we know that in series circuit all appliances are connected one after another. In case of a fault or a failure, one break of the appliances may result in damage of all the appliances and the cutoff of the supplies happens. Let's understand the advantages and disadvantages between parallel and series circuit. If we talk about advantages, we know that the voltage remains constant in parallel. Therefore, each component in the circuit gets same amount of the voltage. We can connect or disconnect a new electrical appliance in the circuit without affecting the other component in the circuit. If there is a fault in one of the electric appliances, the current is able to pass through different parts of the circuit. If we talk about disadvantages, to construct the parallel connection, we need lots of wires. We cannot meet the requirement when the exact same amount of current is required to pass through all the elements. In parallel circuits, we cannot increase the voltage since the resistance decreases in the parallel circuit. I hope you understood the advantages and disadvantages of parallel and series circuit. This is the simplest way to learn circuit in lab. In our lab, there is copper tape and other electronic items which we can start with. So let's start with our paper circuit and understand how basic circuit works on paper. So here we'll be using a copper tape. You can take as much length as you want. Also a coin cell which will power it up, and two LEDs will be using it in this circuit, and of course a paper circuit template. So first let's understand paper circuit. In paper circuit, the major component is the copper tape we are using. The copper tape is a conductive tape made up of copper plating. So it acts as a conductor throughout the circuit. So let's start with making our first paper circuit. So we have our template. You can create a template with pen and a pencil over a sheet of paper, or you can get it printed from the market. So here I have a printed one where I have already built a small circuit on a paper, and I will follow the same path with the copper tape. So what I will do, I will cut a few length of copper tape and I peel it off. Make sure you're peeling it properly, and you can easily paste it there on the template. Make sure do not try to cut, just try to fold it at the 90-degree. If you have chopped it off, then make sure you are connecting right on the top so you can overlap over the circuit. There will be no discontinuity. So I am tearing it off here. Next I will do on the left hand side and quickly turn it according to the template I am having. You can see it here. It is very easy. Now as you can see, we have not sorted all the circuit, so we are making the circuit as per the template. So this is a parallel circuit example where we are going to use two LEDs, the first one and the second one, which is having a positive and a negative leg to the two different terminals. So let's connect the first leg, that is positive leg, to the longer side, and shorter side is the negative, that is cathode. So we'll do similar for the another LED, but before that let's paste it up with copper tape on the top. So this will create the conductivity and the continuity never breaks. So I will try to connect it on the left hand side as well to the shorter side. Make sure there is no such air gap. Paste it properly according to the template you have made. I'll use a coin cell as a power supply. Here I'm using CR2030 lithium ion cell. You can use any other power supply like 9-volt battery with the battery clip over the circuit. A coin cell, so positive side goes to the positive, which is the flatter side, and the negative side goes to the negative, while by folding it up I'll be able to turn on my one LED. So the negative goes to the negative and the positive goes to the positive. This is a copper tape. I'm folding it up so to paste my coin cell properly. So I'll paste it over the coin cell to the positive side, and then I will paste it there on the fold part. So I'll fold my paper to turn my LED on, so the circuit gets complete and the current starts passing through it as it is a conductor. So this is a parallel circuit example. I will try to connect one more LED at the center Let's do it. So this is positive side. I have used one copper tape here. Now I'll tear it off. I'll complete the circuit with the second LED. Now I'll be pasting the positive side to the positive side and negative side to the negative side quickly. So this is a parallel circuit where both the terminals is getting the same potential. So voltage remains the same, the current might differ. So this is a parallel circuit we made. We can make more other circuit like series circuit, closed and open circuit with paper circuit. Let's go to our lab and find some resistors and LEDs to create series and parallel circuits. To make series circuit, I have to connect a component in series to the LED. In series to the LED itself means that I have to connect another component in the line to this LED or where the terminal of the LED is ended. So here we can see the positive terminal, the current is flowing through the resistor and then the LED. As it is not closed, I will try to connect one more LED to the circuit. I'll connect the positive side of the second LED to the negative side of first LED as we are connecting it in series. Now to close the circuit, again I will use a jumper cable and I will try to jump from negative leg to the negative potential of the battery. You'll see the two LEDs started glowing. It means this kind of circuit is called series circuit. In this kind of a circuit, you'll be able to see the voltage drops but the current remains the same. The LED do have different voltage, the second LED do have different voltage. We can easily measure with multimeter. To create a parallel circuit, I again need a power supply, that is 9 volt power supply. I'll connect the positive to positive the way we did initially and negative to negative. Now this breadboard is now powered up. I need two resistors of 1 kilo as I'm going to use two LEDs to connect this in parallel. I'll use two resistors of 1 kilo and connect it in parallel. I have to connect and start from the positive terminal. Now I've connected one of the leg to the positive side of the battery. Similarly, I will do for the another resistor somewhere here. As you can see, the same positive potential is flowing through the whole horizontal connections. So I can take similar power from second resistor as well. I'll try to connect the another LED, that is the positive is the longer leg and negative the shorter leg. Connecting positive to positive side. Again similarly for the second LED. Now if you see carefully, the connection is not yet closed. To close the connection, I need a jumper cable. I'm closing the first LED connection, negative to negative. First LED started glowing. Similarly, I'll do for the second LED connection. The second LED also started glowing. If you see carefully, this circuit is called parallel circuit because the both LED is getting a parallel voltage, the same voltage across the LED, but the current is getting divided as these are connected in parallel. Multimeter. A multimeter or a multitester, also known as volt-ohm meter (VOM), is an electronic measurement device that combines several measurement functions in one unit. A typical multimeter can measure voltage, current and resistance. There are mainly two types of multimeter used, analog and digital. Most commonly used is digital type multimeter. Now let's use multimeter to check voltage and current in series and parallel circuits, and let's test if our theory is correct. This is a common multimeter. You can easily find it in your lab. In this multimeter, you'll be able to see multiple markings here. This marking denotes you can calculate resistance, you can calculate voltage in DC, voltage in AC, current in AC, current in DC. This multimeter can also be used to calculate the continuity across the circuit. So this is a knob, you can easily twist it to your suitable value or type. You can even have a light here. Depending on the multimeter you're having, you can turn it on and off. So these are two probes of the multimeter. This is positive and this is negative. These probes can be further connected or disconnected to calculate voltage and resistance. If you connect it here, you can measure current. If you connect it here, you can measure voltage across the circuit. This is the display unit where the values are displayed, whether it is voltage or current. So, what is continuity? This is a quick audible alarm test using a digital multimeter to determine whether an electric current or wire is complete or broken. This test can be applied to a circuit as a whole or in a section, on individual components or sections of wirings. A break in the continuity can be caused by mechanical damage, corrosion of components, or simply a switch being left open. Your circuit might be right and perfect, and you should not seem to be wondering the fault by looking at every connection, but the better way to troubleshoot is to check the connections running through the circuit. It will help you to determine minor faults. It basically checks whether your circuit is open or closed. Isn't it interesting? Checking continuity is the basics of electronic troubleshooting, and multimeter suits the best for it. Let's learn how to check continuity. To check whether a circuit is open or closed, let's check the continuity of any circuit. To check whether this wire is continuous throughout the line, we have to check continuity of this circuit. So this is the multimeter I'm going to use. You can see a buzzer sound here. We have to shift our knob to the buzzer sound like this. You'll be able to see a battery shine. Now take the two probes, connect the two probes to the two terminals of the circuit or a wire. So you can hear a sound. Whenever you hear that sound, it means the path is continuous. If you won't hear the sound, it means the path is not continuous. Now, let's check the resistance value of the two resistors here. To check the resistance value, I have to switch my knob to the value written here. You may see there are multiple number of values written here. You have to find the exact range of the resistance. I'm switching it to 2K. Now, let's check the resistance. I'm connecting the two terminal to the two terminal of this. It's not showing anything. Let's shift the value more up. So it is 1 million ohms. Let's check the different resistance. We have this resistance here. We can also calculate the resistance value with the resistor calculator, but as we have a multimeter, let's check with the multimeter. So I'm switching my knob to somewhere at 2K. So it is 0.1. Let's reduce the value. Again it's 0.2. Let's shift it to 200 ohms. So the value of this resistance is 150 ohms. So as you can see, we can also calculate the resistance value with the resistor. So we can see we can also calculate the resistance value with the multimeter. So let's see how to measure voltage of any DC device. So here we have multiple number of batteries. So to check the voltage, we have to first switch the knob to the voltage part, which is DC voltage. After switching this, we have to first check whether our terminals are properly connected. Now let's check our first battery. I'll connect positive to positive and negative to negative. Negative to negative. It is 1.9 or 2 volts. Now let's check the another battery. This is almost discharged, so it is 0.3 volt. Now let's check the another battery. This is 6.9 or 7 volt. Let's take another battery. This is 8.9. It means it's a 9 volt battery. This is how you can measure voltage of any DC device. So let's measure voltage across the parallel circuit. So we do have two probes here. We'll connect the first probe to the positive and the second probe to the negative of the circuit. Before that, we have to switch and check whether our terminals are connected properly. This positive terminal should be connected where the V sign is written, and the negative should be there at the common. Now, checking the voltage across this terminal, I have to switch the knob to the V, that is DC voltage. I can switch it to anywhere depending upon the range we are trying to take. You can see the decimal here. Now let's check the voltage across the first circuit, that is the first LED. It is 4.59 volts. Let's check for the another resistor. It is approximately 4.39 volts. As you can see, the voltage across the terminals are almost the same. So in parallel circuit, the voltage remains same. Now let's check the current across the parallel circuit. So this is a parallel circuit. Now let's check current across the parallel circuit. As we know, the current divides in parallel circuit. So let's check. We'll take the two probe of the multimeter and shift the knob to the current part. So this is 200 milliampere current, where it can measure up to 200 milliamps. I will jump one jumper cable which will make this multimeter in series. I'll connect it here and connect this jumper cable to the positive terminal. Now let's check the current across the first terminal, that is the first LED. It is 0.5. Let's check across the another one. It is 0.6. It means the current divide, the two different values shows that the current divides in parallel circuit. Now let's check voltage across the series circuit. As we know, the voltage drops across the terminals. We have two components here. The first one is resistor and the second one is LED. So as per the assumption and the theory we learned, the voltage across the resistor and the LED should change, but the current should remain the same. As we are checking the voltage first, let's check the voltage. First, we have to check the multimeter connection. The positive should be there at the V and the negative should be there at the common. And now we'll shift our knob to the voltage part depending upon the range we are trying to check. So now I'll try to connect for the first terminal. You can easily see I am checking across the resistor. The voltage across the resistor is 4.65. Now let's check voltage across the LED, which is 3.42. So as we can see, the voltage across the terminal is dropping. Now let's calculate current across series circuit. Before we calculate, we have to first understand that whenever we want to measure the current, we always have to keep the multimeter in series. So how to keep multimeter in series? So as you can see, this is a closed loop. I am disconnecting the positive terminal and connecting it the center. Anywhere at the center you may like. Make sure it is not connected anywhere else. It should not short to any other terminals. You can connect it any independent hole here. Now I will jump one wire to this positive terminal. As these are connected vertically, now I can make the circuit in series. Before I connect the probe, I have to shift my terminal to the current part. Let's shift the terminal to the current part. Now we have shifted our terminal to the current part. Let's check the current. To check the current, I have to shift the knob to the DC current. I'll switch backward. Now I'll try to find out and measure the current. Let's connect the two probe to the two end of this terminals. The first red color The positive goes to the positive and the negative will complete the circuit by connecting it to the resistor. The LED started glowing. It is having 0.7 milliampere of current. Now let's go back to the different terminal. I'll first connect the positive to positive again, and I'll switch back to 200 milliampere, and I'll get back to the resistor again. See, it is having 4.5 milliampere. It is approximately 4.5 milliampere. Here you saw the current across the terminal, that is the series circuit, is same, but the voltage divides. Let's look at some interesting facts about electricity and electronic circuits. Do you know electricity travels at more than 70 million miles per hour? Just imagine the flow of current per second then. We even cannot guess its mysterious properties. Do you know electricity also plays an important role in the way your heart functions? Muscle cells in the heart are contracted by electricity, then runs through our body, which is measured by electrocardiogram, that is ECG machines, which are used in hospitals to measure the electricity flowing through a patient's heart, displaying a line that spikes with every heartbeat. Have you ever wondered why birds that sit on the power lines don't get electrocuted? Think for some time. Yes, because if a bird sits only on one power line, it's safe. But if the bird touches any part of the body to another line, it creates a closed circuit and hence causing electrocution. You might have heard about open and closed circuit in this lecture. Do you know why the breadboard we use is called breadboard? Originally, it was literally a breadboard, a piece of wood used for slicing bread. Many years ago, when electronics were big and bulky, people would grab a breadboard with nails or screws to support components. They start connecting wires onto the breadboard to give themselves a platform onto which they can build a circuit. Since then, electronic components have gotten a lot smaller and come up with better ways to connect circuits. Until 1970s, during when the solderless breadboard came available. Nowadays, the term breadboard is commonly used to refer to these. I hope you loved the session. As always, I am putting a few interesting questions for you. Try to solve by brainstorming and tinkering, and try to find out the answers. I hope you enjoyed this session. We'll be learning more interesting topics in our upcoming lectures. Keep tinkering and innovating. Thank you so much for watching this video.